RBCs. We are going to begin with RBCs, and first thing that we start off is with the erythropoiesis. So erythropoiesis refers to red blood cell production. Now we are first going to see a picture of this so that you know what exactly in the bone marrow am I talking about. Can you all see these different cells that we have? These are all the red blood cell precursors. All the red blood cell erythroblast and all those precursors are there. But can you see how they've made an island? There's a group of these precursors, and why have they made an island, and around what have they made an island? So first and foremost, we will label these as all the erythroid precursors, and they have made an island around this cell known as the macrophage. Is there any reason why are all of them trying to stick around and satellite around a macrophage? Because macrophage is going to be their source of iron. Where will they get iron from? Macrophage is going to give them the iron. And why do these cells need iron? Because they have to make hemoglobin. They need to make hemoglobin, so they need a lot of iron. So can I say this macrophage that you have in the center can be called as a nurse cell? It can be called as a nurse cell because it is going to give away all the iron like a nurse feeding. So it's going to give all the iron to these erythroid precursors. So this is overall referred to as an erythroblastic island. This is referred to as an erythroblastic island. Everyone's understood what the island is. Center is what? A nurse cell or a macrophage. What is it feeding? It is feeding iron. Now let's talk about all these cells individually. What are all of these? I've got you a flowchart. Let's start learning. So first rule is I'm going to have blast, 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 blast. Till the time I will talk about something to do with the blast, I'm going to make a line over here, because till the time I talk about something in a blast means it's present in the bone marrow. So all of these things that I have spoken about over here, all of these are going to be present in the bone marrow. So now if they ask you, what are these blasts? Question 1. Pro-normoblast. So first one has to be the pro. Pro means professional. So first one has to be pro. And after that, you've got some 3 normoblasts which are labeled as early normoblast, intermediate normoblast and late normoblast. So simple. Repeating, the first one is pro, and after that you've got early, intermediate and late, and the story is done. You think examiner is going to keep it that simple? No, instead of asking you early, intermediate and late, he is going to ask you the other names, and the other names are B, P and O. What is BPO? I've written it in that order so that you know the mnemonic for this is BPO. BPO stands for basophilic normoblast. P stands for polychromatophilic normoblast, and O stands for orthochromic normoblast. So this has been a previous year question. How are you going to put it in the correct sequence? The correct sequence is going to be BPO, means it is basophilic, polychromatophilic and orthochromic, and that is going to be early, intermediate and late. But everywhere I use the word blast means all of these are present in the bone marrow. One more thing, all of these are going to have a nucleus. All of them are going to have a nucleus that shall be present. Nucleus will be present, but I always used to study that red blood cell doesn't have a nucleus. Exactly. Red blood cell, a mature cell, doesn't have a nucleus, but all its precursors, everything that's in the bone marrow has a nucleus. So what after this? After this, now you will get rid of the word blast. Now you will come to site and site. Reticulocyte, erythrocyte. Erythrocyte is nothing but a red blood cell, right? So reticulocyte and erythrocyte. And please remember, if I ask you which is the first cell in the peripheral blood, the first cell which is present in the peripheral blood, of course, that is going to be a reticulocyte, because this is not having the word blast. No blast, no bone marrow. So blast hai bone marrow, no blast, no bone marrow. This has come in the peripheral blood. Also, this is going to be the first cell without a nucleus. Which is the first cell in this series which is going to be without a nucleus, and that is also a reticulocyte. So reticulocyte is quite, that's why I made a line above it. Below this, everything is going to be in the peripheral blood. So these two are going to be in the peripheral blood, and in both of these, the nucleus is not going to be there. Now, what further do I need to know? I'll again draw this. As you are going from top to bottom, from the first, the pronormoblast, early, intermediate, late, then reticulocyte, and then red blood cell. As you're going from top to bottom, the overall size is going to decrease in that manner. The size of the cell, largest to smallest. Similarly, as you're going from top to bottom, even this is the same thing that you're following for the size of the nucleus. The size of the cell and the size of the nucleus will gradually keep on going from large, small. But nucleus was present till which stage? Nucleus was present only till this blast stage. So can I say for the nucleus, this is going to look something like this. So simple, from top to bottom, the size is decreasing, the nuclear size is also decreasing. Sorted? Your next question will be, what about hemoglobin? Nucleus to ho gaya. What about hemoglobin? So where does the first hemoglobin appear? The first hemoglobin appears in the very first cell. So easy, na? If it's a red blood cell forming, then first cell will have hemoglobin evidence. However, the trick in this story is, it is only seen on which microscope? On an electron microscope. So now you analyze that not everyone has access to electron microscope. It's a really expensive thing, right? So not everyone is going to have access to an electron microscope. That means that if I have a regular light microscope in my lab, what am I going to do then? Or when will I see hemoglobin then? So remember that hemoglobin is seen on light microscope in which stage? In intermediate normoblast. Can you tell me the other name for intermediate normoblast? BPO lagao, put the BPO mnemonic. What is it? BP or O? So you will say this was basophilic, this was polychromatophilic, and this was orthochromic. So indirectly, if I ask you which of them shows you hemoglobin on light microscopy, you will say polychromatophilic will show you. Sounds well? Everyone's okay with this concept? Whatever I have taught you, let's do a recap. Till the time I use the word blast, two things. Both, all of them are present in the bone marrow and all of them are going to have the nucleus. But when they are not having the word blast, matlab site, matlab this has come in the peripheral blood and it is not going to have a nucleus. Then as I go from top to bottom, the size of the cell decreases, the size of the nucleus, everything is going small. And where is the first cell where hemoglobin appears? It is pronormoblast, but with a catch, only seen on electron microscope. So where will you see it on a light microscope? It is going to be an intermediate normoblast. Let me show you the same thing with actually how it's written in the textbook. So let's start. The first one, the first has to be the pro matlab pro-erythroblast. After that, we are going to do BPO. What is BPO? We have basophilic normoblast, polychromatophilic normoblast, and over here it's not written, so we'll write it as orthochromic normoblast. So BPO lagaya, and as I told you, till the time you will say blast, and blast. Where are all of them present? All of them are going to be present in the bone marrow. All of them are present in the bone marrow, because now I come down to the next one. I come down to the site. When I say site, and site means, has the nucleus been chucked out? Can you see the nucleus has been chucked out? Now the nucleus is not going to be there and all of them are going to be present in the peripheral blood. Whatever we had studied, have you been able to analyze? Also see, look at the overall size of the cells. Is it going from biggest to small? Dekho, this is biggest, then smaller. Everything is going chota. That is how you analyze the size part of it. So the size of it is also going to go down. We'll be practicing a few questions in a while, but I hope everyone's okay with this. Out of all of these, what I now have to talk about in detail is this reticulocyte. It is their favorite most question. Reticulocyte is going to be their question, and I call it a reticulocyte, but I also give it another name. So now listen to me very carefully. When they are talking about something known as a reticulocyte, they might sometimes also call it a polychromatophil. They might also call it a polychromatophil. Don't get confused. I am not calling it a polychromatophilic normoblast. No. I am not calling it a polychromatophilic normoblast. I'm not using the word blast. I'm just stealing the word polychromatophil, because reticulocyte and polychromatophil means the same. How are they same? Exactly the same. The only difference is what color have I given. On the basis of that, I will make the terminology. Means, what is this usual color that we use, guys? What is the usual color that we use? We use the Romanovsky family of stains. On a Romanovsky family, tell me, what if I zoom in and you have to analyze this very well. Some cells you are seeing which are looking completely red. But if you look at this cell over here, firstly tell me the size. Is it bigger? Yes. तो ये जो था, this छोटा thing, this was the routine red blood cell. But the other cell, which is bigger, number one, it is bigger. And number two, if you look carefully, has it got a red and a blue mixture? Is it reddish bluish? So which is the cell which is big and blue? The big and blue cell is a polychromatophil. And why? It's got a red-blue mixture. Red, blue, multiple colors. It's got a red-blue mixture. Red-blue mixture basically means multiple colors, and multiple colors basically means polychromatophil. Polychromatophil matlab multiple colors. Polychroma means multiple colors. So on that note, please repeat with me that if I have used a Romanovsky stain and I'm getting multiple colors like blue pink ka mixture, I will call it a polychroma, multiple colors. But now you want to know, why is it blue? Why is it got this polychroma appearance? So now you used something known as a supravital stain. And let me zoom in and show you, and I'll make you understand the concept of a supravital stain. So what I have in front of me is a supravital stain, and please remember, this supravital stain ka examples are two which you will first learn with me. There is something known as new methylene blue, and the other one is known as brilliant chrysal blue. New methylene blue and brilliant chrysal blue are the two blue color stains. So something blue is going to come up in front of me, and I can very well see the blue. I can see these cells have got some blue color granules, right? So now your question is, what are these blue color granules? They are nothing but a reticulum of RNA. They are nothing but a reticulum of RNA. So now you understand why do I call this cell a reticulocyte? Because they will ask you what is the concept, what is the composition of a reticulocyte. A reticulocyte matlab reticulum, RRR. Reticulocyte matlab reticulum of RNA. These are the blue color dots are RNA. And now you will understand that what is the concept of a supravital stain. Dekho, break the word. Supravital means you are going to do staining in the living state. Matlab, what does that mean, ma'am? Staining in the living state. In other stains, do I kill the cells? Kind of. Because please remember, when you want to stain RNA has kept one condition in front of you, one shart, one condition it has kept, that I will only show you my color if you keep me in living state. If you kill me, I will not show up. So you will have to keep it in the living state. How do you keep it in the living state? The rule is, do not use alcohol. If you will use alcohol, the RNA is going to vanish. So there is going to be what? There is no methanol fixation. Many students ask me later on, what is the concept of supravital stain? What do you mean by that? So I say I basically don't use alcohol. I don't use alcohol because I want to keep my cells in what state? I want to keep my cells in the living state. If I keep them in the living state, then this RNA will be visible. So if you keep it in the living state, RNA will be visible. That is known as vital, supravital stain. And what are the two examples? New methylene blue, brilliant chrysal blue, out of which new methylene blue is the best stain that you have. So what would you see in most of the cases is a new methylene blue. So now coming back, it's only a difference in the stain. If I've used a supravital stain, what can you see? If I've used a supravital stain, I'll call it a reticulocyte. If I've used a Romanovsky stain, then I'm going to call it a polychromatophil. But are they exactly the same cells?